Hello everyone, welcome back to the second lecture of week 10. Here we will go through the first derivative for extremum value and the higher derivative test for the extremum and local maximum and minimum value. As we have seen in the previous one that the points where the extreme values exist are called critical points. Here what will be the test whether which we will recognize or identify those critical points. So, the first one we call it the first derivative test, and I mean you can ask that why we are going only the first derivative test. We do have the higher derivative test, but this theorem is based on only the first derivative test. Let me read for you. So, let f be a differentiable function on a interval defined on an interval I, and let a be any point in I, then x equal to a is a point of local maximum value of f if dash of a equal to 0. F dash of x changes sign from positive to negative as x increases through a, right. That is, f dash of x is greater than 0 at every point sufficiently close to and to the left of a. So, something like this, right. So, this is your function and this is the value of a. So, we are talking about this, right. So, f dash of x is f dash of x f dash of x is greater than 0, and similarly here f dash of x is less than 0, sufficiently close to this one, right. And for a minimum value, so look at for this point. So, this is your axis and this is your points here x equal to a, and look at this value, just the opposite, the reverse of this. So, x equal to a is called the local minimum point of a, where f dash of a becomes 0, f dash of a equal to 0, and f dash of x changes sign from negative to positive as x increases through a. That means f dash of x is less than 0 at every point sufficiently close to and left of f. So, what is the left of a? This is the left of a. So, this means f dash of x is less than 0, while this one is f dash of x is greater than 0 on the right hand side, right. And the third one, that is f dash of a equal to 0 and f dash of x does not change sign. Here you will see that this is less than 0 to greater than 0 become, and that is why f dash of a equal to 0 will be a local maxima or local minimum depending on how the sign changes from left to right, right. In this case it was a local minimum, right. But the third one, where f dash of a equal to 0 and f x does not change sign as x increases through a, that is f dash has the same sign throughout in the complete neighborhood of a, then a is neither a point of maximum value nor a point of local maximum value. In such a case, the point is called point of inflection. And these are the algorithm where you will put directly, and we will follow directly to find out the local maxima or local minima of a given function. So, put y equal to f x and find out dy by dx, and put dy by dx equal to 0 and solve this equation for x, and let c1, c2, cb be the roots of the equation, and these all roots are called the critical points or stationary values of x, and these are the possible points where the function can attain a local maxima or local minimum. So, we test the function at each one of these points and consider x equal to c1, where dy by dx changes its sign from positive to negative as x increases through c1, then such a point c1 is called local maximum point. Similarly, dy by dx changes its sign from negative to positive as it increases through c1, then the function attains a local minimum x equal to c1, right. If dy by dy does not change sign as x increases through c1, then x equal to c1 is neither a point of local maximum nor a point of local minimum. In this case, it becomes the point of inflection. Similarly, we deal with the other points of x equal to c2, c3, c4 and so on. So, based on this first derivative test for local maxima and minima, can we find local maxima and minima of the function f x equal to x cube minus 6x square plus 9x minus 8, right. So, y is given, y is equal to x cube minus 6x square plus 9x minus 8, then dy by dx can be obtained. and that will be 3x square minus 12x plus 9, and it can be written as 3 into x square minus 4x plus 3, taking 3 as a common. The critical points of fx is now equating this equal to 0. So, this will give you x equal to how much? X equal to 1 and 3, right. Now, find out f of 1 and f of 3 first, right. So, okay, I mean that is the one point, but we have to use the test of the first derivative test. Therefore, I have to find out dy by dx, and either it changes sign or not. So, how the dy by dx changes between 1 and 3, and since domain is the whole real number. So, we have 1 and 3 as the critical points, and we have to check y dash or f dash of x in these intervals minus infinity to 1, 1 to 3 and 3 to infinity. And as you can see, minus infinity to 1, putting y dash equal to 0 only, and you will see that this is a positive one and this one will be negative one, right. So, the negative one and the positive one. So, sign changes from plus to minus, minus to plus, and henceforth x equal to 1 become the point of a local maxima and x equal to 3 become the point of the local minimum value. Example 2, find all the points of a local maxima and local minima as well as the corresponding local maxima and minimum value for a function fx equal to x minus 1 ka whole cube into x plus 1 ka whole square. So, let y equal to fx and then find out dy by dx, equate is equal to 0, and you will find out the 3 points x equal to 1, minus 1 or minus 1 by 5, right. So, you have a 3 points here, minus 1, this is 1 and minus 1 by 5, minus 1 by 5 here, minus 1 by 5, this is 0, right. So, these 3 points are the critical points, and we have to find out what is the sign of y dash or dy by dx, right. In those interval minus infinity to this one, minus 1 and then minus 1 to minus 1 by 5 and then this one, right. So, doing the same thing, see here the dy by dx, all these are the dy by dx sign. So, sign changes plus to minus here, minus to plus here and then plus to minus here, plus to plus here, there is no sign change as x equal to 1. So, x equal to 1 become point of inflection as it does not changes the sign, plus is right, and x equal to minus 1 is here and it changes from plus to minus 1, that means it become a local maximum value, right. Similarly, as you can see minus 1.5, it changes the sign minus to plus and then become the local minimum value. So, you will find out the local minimum value by putting x equal to minus 1 by 5. So, by finding 1 f equal to minus 1 by 5, that is equal to minus 3, 4, 5, 6 divided by 3, 1, 2, 5, and this will become your minimum value of the function. Similarly, find all the points of local maxima and local minima of the function. Function is given x cube minus 6x square plus 12x minus 8, and let y equal to fx equal to x cube minus 6x square plus 12x minus 8, then dy by dx equal to 3 into x minus 2 ka whole square. Equate dy by dx equal to 0, this will give you x equal to 2. And now, there is only one point between the minus infinity to infinity. So, we have to check dy by dx, and as you can see dy by dx does not change its sign. So, x equal to 2 is a critical point, but this critical point is called the point of inflection. It does not have the local maxima or local minimum value, right. So, I think you understand how we reached the conclusion that the critical points, which critical point is going to be give you the maxima or minimum value, as dy by dx changes their sign at that point, that may be give you a minimum or local depending on from the positive to negative or from negative to positive, right. But it does not change the sign, then the point is always point of inflection. And similarly, this point as you can see here, minus 1 does not changes the sign. So, it is a point of inflection. Here it changes the sign from positive to negative. So, it is a local maxima. and from minus to positive. So, it is a local minimum. Now, what happens when a function does not come in a criteria of the first derivative test? So, use the higher derivative test. As I had already told you that there exists some higher order test as well. So, here is the higher order derivative test, and let f be a differentiable function in an interval I, and let C be an interior point. So, C belongs to some interior point I. So, f dash of C, f double dash of C, f triple double of C, or f n minus 1 C, and f n C exists and is non-zero, right. So, f be a differentiable function such that f dash of C is equal to f double, all these are become the equal, and f n C exists and is a non-zero. It is not only this, but it is become a 0 as well, right. So, all this derivative is equal to 0 and f n C exists, but it is non-zero, then n is even and f n C is less than 0 will become x equal to C as a point of local maxima, and if f n C is greater than 0, x equal to C become the local minimum value, and x equal to C, and if n is odd, then neither point of local maximum nor a point of local minimum. And how we have to find out? Firstly, take the first derivative, put the first derivative equal to 0. These are the critical points where we have to check the higher order derivative test. So, f double dash of x, x equal to C1, then f double dash of C1 is less than 0, then x equal to C1 become the point of local maxima, and greater than 0 will become the local minima, and equal to 0 again you have to check f triple dash of x and so on, right. So, let me start from the first one, the examples of this. I hope you believe, you understand this, right. So, firstly you have to check f of x and the point C. So, this is equal to 0, this will give you some of the points C1, C2 and so on, these are the critical points, and f double dash of x equal to 0, then C1 does not have a local maxima or local minima. You have to check the higher derivative order test. So, let have that based on those higher derivative order test of first problem. Find all the points of a local maxima and minima and the corresponding maxima and minimum values of the function f x equal to minus 3 by 4 x to the power 4 minus 8 x cube minus 45 by 2 x square plus 105. So, we have f x equal to minus 3 by 4 x to the power 4. So, f dash of x equal to, this will comes out minus 3x into x square plus 8x plus 15, right. It is easy to derive it. And what are the critical points? Just equate is equal to 0. So, this will give you how many critical points? We have 3 critical points, 0, this will be minus 3 and this will be minus 5. These are the possible 3 points where local maxima or local minimum may exist. Now, calculate f double dash of x. F double dash of x will become minus 9x square minus 48x minus 45, and x equal to 0. You have a 3 points, right. You have a 0, this will be minus 3 and minus 5. So, put all those values, find out f double dash 0. F double dash, we are checking about this. So, f double dash of 0 is equal to minus 40, which is less than 0. This means the 0 point give you the local maximum value. So, this will give you the local x equal to 0 become the local maximum point for the function, and the local maximum value of f x at x equal to 0 is equal to f0, and you can calculate f0 from the given function, that is equal to 105. So, 105 is the local maximum value. Similarly, we can test for minus 3. So, f double dash of minus 3 is 18 and 18 is greater than 0, hence for the local minimum exists, and this minus 3 become here 0 become the maximum value, and this minus 3 become the minimum one, right. And what will be the minimum of? So, calculate f of minus 3, that will be 231 by 4. So, this will become local minimum value of the function. Similarly, test for minus 5. So, f double dash of minus 5 is minus 30, which is less than 0. So, this will become a local maximum. So, you have 0, minus 3 and minus 5. Here is the maximum value, here is the maximum value, and here is the minimum value, right. So, that is your answer. Similarly, find all the points of a local maximum or minimum and the corresponding maximum minimum value of the function of this. So, we can find out f dash of x first, f dash x equal to 0, and this will give you 1 and 6 as a two critical points where the local maxima or minima may possibly exist. So, f double dash of x and f double dash of 1, calculate this, is equal to minus 30 is less than 0. That means it will become a local maximum. So, 1 is the local maximum, here 1 and 6. So, this is the local maximum, this is the local maximum, and what will be the value of f of 1 is equal to minus 3. So, maximum value is minus 3. Similarly, you will find out f double dash of 6 which is greater than 0, that means this will give you local minimum value, and what will be the local minimum is f of 6 equal to minus 128. So, this will become a minimum, and what will be the, this will become minus 128, minus 128. So, this is your answer, right. You have find out the maximum value, minimum value by the first taking the first derivative equal to 0 will give you the critical points. Find out those critical points, the higher derivative f double dash of x at that point, and look at the value that it is less than 0 or greater than 0, and so on. And so, I believe that this will be a good thorough lecture for your maxima and minima, and in the next lecture we will see the application of these maxima and minima of calculus part, and I believe that you remember all those derivatives. So, thank you so much.